Hey y'all, welcome back to the channel. It's Amanda, and it is always great to have you here. Today, I will discuss programming in C++ Chapter 6 User-Defined Functions. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. So let's dive right in and get our hands dirty with some code. In algebra, a function can be considered a rule or correspondence between values, called the function's arguments, and the unique values of the function associated with the arguments. Thus, if then and where 1, 2, and 3 are the arguments of the function f, and 7, 9, and 11 are the corresponding values of f, the C++ function POW has two parameters. In C++, the concept of a function, either predefined or user-defined, is similar to that of a function in algebra. For example, every function has a name, and depending on the values specified by the user, it does some computation. This section discusses various predefined functions. The TOLOWER function takes one parameter of type int. Some of the predefined mathematical functions are POU, /x, we, SQRTX, and floorx. The C++ function floorx calculates the largest whole number that is less than or equal to x. The square root function, SQR to x, calculates the non-negative square root of x for x equals sign 0.0. For example, SQArt 2.25 is 1.5. The function scoart is of type double and has only one parameter. In C++, predefined functions are organized into separate libraries. For example, the header file iostream contains IO functions, and the header file cmath contains math functions. User-defined functions in C++ are classified into two categories. Value-returning functions are functions that have a return type. These functions return a value of a specific data type using the return statement, which we will explain shortly. Note that the function main has used a return statement to return the value 0 in every program we've seen so far. Void functions are functions that do not have a return type. These functions do not use a return statement to return a value. We will first discuss value-returning functions. A call to a value-returning function with an empty formal parameter list has the form function name. Next, we will discuss another type of functions, right after this. The previous section introduced some predefined C++ functions such as POW, AEBS, isLower, and tupper. These are examples of value-returning functions. To use these functions in your programs, you must know the name of the header file that contains the function's specification. Stream variables should be passed by reference to a function. You need to include this header file in your program using the include statement and know the following items: the name of the function, the parameters, if any, the data type of each parameter, the data type of the value computed, that is the value returned, by the function, called the type of the function. An actual parameter is a variable or expression listed in a call to a function. Because a value-returning function returns only one value, the natural thing for you to do is to use the value in one of three ways. Save the value for further calculation. For example, x equals sign POW 3.0, 2.5. Use the value in some calculation. For example, area equals sign pi asterisk pow radius 2.0, or print the value. For example, count abs minus 5, endl. This suggests that a value-returning function is used in an assignment statement as a parameter in a function call in an output statement. That is, a value-returning function is used called in an expression. A return statement can only return one value. Before we look at the syntax of a user-defined value-returning function, let us consider the things associated with such functions. A variable for which memory is allocated at block entry and deallocated at block exit is called an automatic variable. When using a reference parameter, a constant value or an expression cannot be passed to a non-constant parameter. The first two situations are illustrated throughout this book. Chapters 8 and 10 discuss the third situation, when arrays and classes are introduced. Recall that when you attach and after the data type in the formal parameter list of a function, the variable following that data type becomes a reference parameter. Let's move on to our next section, right after this. When a function is called, memory for its formal parameters and variables declared in the body of the function, called local variables, is allocated in the function data area. Recall that in the case of a value parameter, the value of the actual parameter is copied into the memory cell of its corresponding formal parameter. In the case of a reference parameter, the address of the actual parameter passes to the formal parameter. That is, the content of the formal parameter is an address. A formal parameter is a variable declared in the function header. During data manipulation, the address stored in the formal parameter directs the computer to manipulate the data of the memory cell at that address. Thus, in the case of a reference parameter, both the actual and formal parameters refer to the same memory location. Consequently, during program execution, changes made by the formal parameter permanently change the value of the actual parameter. Value parameters provide a one-way link between actual parameters and formal parameters. Earlier in this chapter, in the discussion of value-returning functions, you learned how to use value parameters only. You can also use reference parameters in a value-returning function, although this approach is not recommended. By definition, a value-returning function returns a single value. This value is returned via the return statement. If a function needs to return more than one value, as a rule of good programming style, you should change it to a void function and use the appropriate reference parameters to return the values. A program that tests a function is called a driver program. The previous sections presented several examples of programs with user-defined functions. Identifiers are declared in a function heading, within a block or outside a block. A question naturally arises. Are you allowed to access any identifier anywhere in the program? The answer is no. You must follow certain rules to access an identifier. The scope of an identifier refers to where in the program an identifier is accessible, visible. Recall that an identifier is the name of something in C++, such as a variable or function name. This section examines the scope of an identifier. First, we define the following two terms: local identifier, identifiers declared within a function or block. Local identifiers are not accessible outside of the function block. Global identifier, identifiers declared outside of every function definition. Also, C++ does not allow the nesting of functions. That is, you cannot include the definition of one function in the body of another function. The scope of a function name is similar to the scope of an identifier declared outside any block. That is, the scope of a function name is the same as the scope of a global variable. In C++, is called the scope resolution operator. Before considering an example to explain these scope rules, first note the scope of the identifier declared in the for statement. C++ allows the programmer to declare a variable in the initialization statement of the for statement. If a function is overloaded, then in a call to that function, the signature determines which function to execute. The value of a global named constant cannot be changed during program execution. You can assign a constant value as a default value to a reference parameter. Don't forget to like, subscribe, and hit the bell icon so you won't miss out on future tech adventures. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Catch you later, techies.